Howdy, y'all. My name is Myrle, for Matt, that rhymes with Pearl. And this is Goutham Veeramatchanani, which is perfectly easy to pronounce, and I don't know what Matt's problem is. And this is Baljeet Saini. And we will be talking with you about the progress we've been making on Asserts since the last year. I'm a director of engineering. Goutham is product manager, and Baljeet is lead software engineer at BlackRock, one of our customers who's been helping us to prove this out. So let's talk first about what this looked like before we started. Last year, we had just acquired Asserts, and we were looking at integrating it into our platform, but we had a different world before this, right? What were people using to troubleshoot their applications without Grafana Cloud? Let's start here. This is an alert that's pretending I'm a manager, because I am. We just got this alert on my team. Let's read it for a second. We've got a search products latency SLO burn rate is very high. So what's going on here? It looks like search products, the service via which my customers look at the products that I'm trying to sell them, is having a high latency period right now. This is a little problematic because this means that my business may not be earning money right now. On my team, I've got 6 full-stack devs who know how to manage and operate this service. However, 3 of them are in Europe. Let's see. It's about 10:30 at night. They're at a birthday party. They might be drinking. I don't know. We've got 2 ladies in NASA. We've got Elena. She's very experienced, but she's on vacation. We've got Brian, who unfortunately and unexpectedly is out sick. And the second lady in NASA in North America is Seema. She just started 2 months ago. She's smart. She's ambitious, but she's new. And she needs to help us figure out how to fix this. So first thing she does is she goes to that dashboard that Elena showed her during the onboarding process, and she sees that we've got a lot of front-end errors coming up. It's what I said. The product service is down, and our customers aren't able to reach our website to buy our products. It's costing our business money. I've let my boss know what's happening, so she's in the loop, but pretty soon it's going to be the department head calling me and asking for an update. So Seema digs in. She finds an error. She looks at one of these errors. She looks at a couple more of these errors. She sees they all say pretty much the same thing. 500 errors from the product's API. So which services are involved? Well, probably the product service, but which other services are involved? She goes to this wonderful architecture diagram that Elena put together for her, and actually, Elena's really good at keeping this up to date. She goes through every once in a while and checks it, but sometimes people don't tell Elena about the changes they're making, and Elena can't change it like continuously. So maybe it's up to date, maybe it's not. Even with this architecture diagram, Seema's now going to have to find the dashboards for all of these services too, right? Are these dashboards high enough quality? Do they have the information that Seema needs? Are they similar to each other, or is she going to have to work with different language every time she switches between dashboards? Looks like Seema managed to find that dashboard for the product service. She also found the dashboard for the recommendation service. And she's found the dashboard for the feature flag service. Actually, they look pretty good. And now she's found the dashboards for the SQL database, but which instance of the SQL database does she need to look at? This is really hard for Seema. This is really hard for almost any engineer, even if they're not new to the project. And we hear this from a lot of our customers. They have all of the data they need. Everything they need to troubleshoot, it's there. It's in the system. They even have dashboards for all of it. But finding the right dashboards, accessing it during an incident, that's really hard. And it's especially hard because it requires people to know where things are, even people who are new or people who have switched between teams. And that slows people down, and it means businesses lose money. So we've been working on making this better, making this easier. And Goutham is going to show us what the Asserts team has been working on in order to integrate all of these insights into one place. First, he's going to explain how the system works, and then he's going to give us a demo.
Hi, everyone. I'm Goutham Veeramachaneni. I'm the PM for Asserts. I'm also a Prometheus maintainer. And I really, really loved the product when I saw it because it's very much built on top of Prometheus. So before we kind of look at how Seema and Elena could now leverage Asserts to solve the same problems, let's kind of understand how Asserts works. So Asserts looks at all your metrics to understand all the components in your system. For example, if you have node exporter metrics like node uname info, or Prometheus Kubernetes metrics like kube node info, we understand what nodes exist in your system. Similarly, from kube pod info or from kube deployment info, we understand what deployments exist in your system. If we see red metrics like HTTP server duration seconds, from OTel, from Flask, from all the popular Prometheus frameworks or Prometheus instrumented frameworks, we understand what services are running and like what red metrics they have. If we see metrics from MySQL, we understand this deployment is a MySQL deployment. Once we understand all the components in your system, we then use traces, service graph, service mesh to understand the dependencies between these components. We put together all of this into a graph database, and we produce something that looks like this. It looks super cool, but it's also super scary and super dense. This is not where Asserts ends. But it understands all the components and the relationships between these components. It goes one step further. It not only discovers stuff in your application and infrastructure, it also then starts to monitor key KPIs and understand healthy states for services. For example, it knows that checkout service usually gets 50 requests per second, and it answers in 200 milliseconds, for example. It knows MySQL typically gets like 100 connections on a stable day, and then the maximum limit is 500. If anything close to that, it's saturation. So once it understands the healthy states, it starts highlighting changes, anomalies, and issues in these systems. It then puts together all of this information to help you troubleshoot quicker. All right, let's go back to the documentation that Elena wrote. Well, we all know engineers love documentation because they never need to update it. Now let's switch to the demo. Let's see what happened. Like, just remember this. There's a product catalog service talking to recommendations and feature flag. Now, let's switch to the demo. We can go to Asserts in the panel here. And by default, Asserts will pull in all the information for all your services. You can also scope it down. For example, if you're going to troubleshoot product catalog service, you can just say, hey, just show me product catalog service, connected services. And it automatically pulls in all the services that are connected to the product catalog service. Again, there's a bunch of services here, but for me, this is already quite good. And I can see that the recommendation service is calling the product catalog service, not the other way around. Suddenly, this becomes the runbook, and this becomes the documentation because it automatically is updated always as the requests change. The service graph changes, and then automatically Asserts understands the architecture. But where Asserts really, really shines is the troubleshooting workflow. Let's say Elena or Seema has gotten the same alert that we saw recently, the same product latency alert. You can add a link to your alerts that can take you to the RCA workbench. And Asserts automatically pulls in, for an SLO created on the product catalog service, it can pull in all the connected services that are also having assertions or anomalies or changes in that period. And if you kind of go look at the graph, it's a very similar graph, but it has a fewer components because the other components did not have any errors or issues in that time range. So automatically, it kind of scopes it down to the more interesting components of the system. The timeline view kind of gives you a heat map of all the issues, and you can also use the summary view to kind of expand out all these issues. It might be hard to see in the back, so just assume it's all cool when I kind of talk through this. So this is the timeline view, and we can see that we are seeing some blue things, which is like changes, and looks like a feature flag got deployed. It's called product catalog read from Postgres, feature flag state equals 1. And then after that, we see that the Postgres connections are going haywire, like it's just up and down, up and down. And then we see that the product catalog service has started crash looping. And then we also see that the list products endpoint is having issues. The front end is not able to list products or recommendations. And again, the recommendation service is having issues listing products here. Again, we saw that, again, the recommendation service is talking to product catalog service. So if the product catalog service is having issues, probably the recommendation service is too. Now let's troubleshoot this product catalog stuff. I'm going to look at the database because maybe it's a database issue. And automatically, we understand this is a Postgres instance, and we pull in the Postgres integration dashboard. We can see that the number of rows being queried, there's some spikes, there's some QPS connections, and there's like a spike in connections and down, and spike in connections and down. It generally looks quite healthy. If we look at the Kubernetes monitoring context, again, we know this particular metric, this entity, is running in Kubernetes, so we bring in Kubernetes monitoring. We see that there's spikes in memory usage, but I did not set any limits yet, so it's probably OK. I should make a note to set that. Then let's actually go troubleshoot the product catalog service. If you go look at the AppOly, which is OTel-powered data, we can see that it is having high latency, it's having a bunch of errors, and it's having like requests coming and going, which is kind of consistent with it dying and restarting. Maybe it's ooming. We can also kind of check that. We see that there's 200 MB limit being set, but the service itself is using like 15, 16 MB. So it's a very, very efficient service that just dies. Now let's try to kind of like take a look at our logs for the service. We see that basically there are some null pointer exceptions. Oh, wait, what is this? This you need to see. There are some errors that say sorry. And I would like all my errors to say sorry from now on. So it says too many clients. There's a null pointer exception, essentially in Go. It's coming from database SQL, sql.go. So it looks like somebody turned on a feature flag to read from Postgres, and there's some code level issue that's basically killing the service. The first thing we need to do is like roll back the change, and we also can detect feature flag changes being rolled back. In Kubernetes, we automatically detect version changes, when a deployment changes, when a new container image is deployed, and we kind of bubble up all of that information for you folks so that you can correlate changes and issues very easily. All right, that is the demo that I have. Let's kind of go back to the slides. My manager wanted me to record the demo just in case. I did not. It worked out. So yeah, to summarize, Asserts not only discovers all the components in your system, it understands the healthy states and highlights it, and it puts together all of this information in the RCA workbench, which can easily help you troubleshoot. You've heard about Asserts last year when we announced the acquisition. Well, we spent the last year integrating Asserts with every part of Grafana Cloud, and we're announcing GA integration with Kubernetes Oli, AppOly, and SLOs, and we're like a couple of months away from front-end Oli and AWS Oli. We plan to put Asserts in every corner of Grafana Cloud, so even if you're looking at a dashboard, we will automatically understand what entities exist in the dashboard and kind of bring you to this context that helps you kind of understand the dependency graph and helps you troubleshoot. All right. Does this sound too good to be true? Yeah, it does sound too good to be true, but I would like to invite my favorite customer, Baljeet, to kind of share his journey with Asserts.
Thank you, Goutham. So my name is Baljeet Saini. I'm an engineering lead in the Observability team, which is part of the larger Aladdin engineering group at BlackRock. Aladdin is BlackRock's investment management platform, and it is provided as a hosted service, and it covers all areas of asset management, like trading, compliance, and portfolio management. And my team is responsible for providing the tools and services which enable the observability of this platform. So as Goutham mentioned, and we also saw in the keynote, Asserts is intelligent enough to understand a lot of different metrics, these standardized metrics that come from Kubernetes or which come from tracing. At BlackRock, we had a slightly unique situation. We follow this overarching principle at BlackRock, which is called One BlackRock. And the way it applies to software development is that we try to have consistency in the way that we build, deploy, and monitor our applications. So most of the applications that we have, they produce a rich set of standardized metrics. And these metrics then power internal dashboards and our monitoring and alerting. when we learned about Asserts, what we wanted to know was whether Asserts can use this existing set of metrics and provide us new insights. These insights, which we may not be able to build on our own because it is too difficult to do or not possible with what we have. So we were delighted to know, and working with Goutham specifically, we were able to map all of these existing metrics pretty easily into the Asserts model. So Asserts has this safe model. We were able to get our existing data into this model, and then Asserts started providing us new insights into it. So to give you an example of how we are using Asserts, or starting to use Asserts actually, let's take an example of a simplified trading workflow. So if somebody presses a button to book a trade, there are a few things that are going to happen. So we need to get the security details, we need to get market placement information, we need to run trade compliance checks, and once everything checks out, we update the trade information in the database. So in case something goes wrong, this is the kind of troubleshooting workflow that would happen. So an operator would receive an alert about slowness in trade booking. They would then reference runbooks to figure out which area of the trading ecosystem is having trouble or problems. And eventually, they might figure out that the problem is in the compliance workflow. Then they have to go and check existing dashboards that exist for the various compliance services to figure out what is going wrong over there. They will also check logs, and they might have to copy some information from the dashboards, such as transaction IDs, over to wherever they are checking the logs to be able to manually correlate all that information. And all of this correlation that is manually done will eventually help them figure out how to troubleshoot further. So as you can see, this requires the operators to have a good understanding of these various workflows. And it's not easy for somebody who is new to just pick this up. And as Goutham also showed, documentation might exist, but the documentation might be out of date. So how does this change with Asserts in the picture? Actually, one slide to just show what they would look at without Asserts. So there are a few different dashboards that they're looking at. And then there is another dashboard for logs, and they are copying information across to figure it out. Changes a lot with Asserts in the picture. So you receive an alert again, but now instead of looking at runbooks, which again may be outdated, you are able to pull up a live view of the system and focus in on the trading segment. And hopefully, it shows you right there that there is slowness in the compliance workflow. And then you can dig into the trading compliance workflow itself and pull it up in the RCA workbench, where it is going to show you a list of prioritized assertions and pull up all the connected services that may be having problems at the same time. So this is much better than what we had without Asserts, because now you have all the relevant information in one view. It's all up to date, and you're looking at, Asserts is helping you correlate all of this information without having to go anywhere else. So this is the kind of view that we would see with Asserts. The screenshot on the left shows a view of the entity graph. These are all the connected services that are being used in that trading workflow. And there is a screenshot of the RCA workbench where all of the assertions are now being prioritized and represented, and all of the connected services are being pulled in. So in summary, Asserts helps us speed up the analysis and troubleshooting. And it's doing this by providing us all of this contextual data and automatically doing correlations, which help us to resolve problems faster. That's all I have. Handing it back. Cool.
So thank you, Baljeet. That's fascinating what y'all have been doing with Asserts, and it helps make me feel a little proud too. So thank you. You all may be wondering what you need to do to get started with Asserts. So let me give you a short overview. For now, you need to have Grafana Cloud Advanced. We are going to make this available to everybody in 2025, but for now, this is only for Grafana Cloud Advanced customers who are using Kubernetes monitoring and application observability. I hope that makes sense because we're trying to correlate data from multiple systems, and Kubernetes monitoring and application observability send the kind of rich signals that help to make this a useful product. Thank you.